All right, welcome to third grade unit 3. My name is Jake Beers. I'm the elementary science TOSA here for Springdale Public Schools, and we're going to walk through this third grade unit. So this third grade unit is all about forces in motion and then magnetism. And so we're going to explore those concepts through a lot of different hands-on activities, multiple picture perfect lessons, and some additional investigations. So we're going to just go ahead and jump right in. So in your kit, you'll find things for this first activity. It's from the book Sheep in a Jeep. It's obviously a little kiddie book, but it's more about forces in motion and getting kids in this idea of a car and movement. It sets up our investigation. So the first picture perfect lesson you use is Sheep in a Jeep. It is a board book. It does feel a little young, and again, it's just a short sum we'll read aloud to really just set up the experiment for you. So in Sheep in a Jeep, kids are going to be rolling things down ramps and exploring with those. I like to use whiteboards for ramps. They're cheap. You usually have them in their classroom. And then anything for stacking. So it's blocks, or I always use textbooks, or just any book. Anything you have to get some height on your ramp. And then kids are going to be doing some different investigations, different heights of the ramp, rolling the car down the ramp, and then measuring the distance it travels. We don't have animals to put on top of the Jeep or in the Jeep, so we just use the car itself. And then the investigation calls for them to roll on multiple surfaces, so you can test the carpet and then the tile floor in your classroom. I think that's the easiest thing to do. You could try sandpaper as well if you have access to that, but it always just kind of seems like carpet just works so much better. So I'd recommend using carpet or a smooth and a rough surface and letting kids explore the idea of friction as things roll down a ramp. As a tack on that, students need to design their own investigation. So you can use the ramps in the cars and have students come up with their own investigation that they want to explore. Maybe it's additional ramp height or ramp length. Does the length of the ramp matter? It could be trying different surfaces. It could be trying different cars. It could be something completely different. But they need there's some time built in for them to design their own investigation and then explore that. Anytime you are collecting data, it's great to graph it. So there's a lot of opportunities to graph data with the Sheep in the Jeep investigation. So that's one of our previous lessons that was in the curriculum, so you may be familiar with that one. A new one that we're going to add in comes from the new Picture Perfect book, and it uses this book, Clink, and then Machines with Springs. There are two new texts, and you have copies of these coming to your buildings. And so in this one, we investigate with wind-up robots. And so you're going to get about 6 of these wind-up robots in your classroom to use. And so these wind-up robots have a turn on the side, and then they walk. And so students are going to explore with the number of cranks and measure the distance it travels. Again, a great opportunity for measurement data for some graphing. Students are then going to, there's a video on taking apart, and they'll learn that they're actually a certain type of spring. And so they'll learn about different types of springs through this book and try and identify the spring used inside this wind-up robot. The next activities are students within the same lesson is students are then going to be building these wind-up toys, and they use a rubber band, a spool, and a washer, and they wind up this, and then they travel. Let me see that one over here. So the challenge with these is the spools I bought are kind of small, and so unfortunately they don't work great. Here's another one. That one worked pretty well. So that they just travel around, and so kids get to build these. You have the spools coming, the washers coming to you. The things you'll need are small little pencils, which I guarantee you have in your classroom, and rubber bands. So those materials are also part of this unit where kids are designing a rubber band and talking about how these spool racers work. If you have bigger spools in your classroom, those tend to work a little better. And also found that a lot of spins to get them to go. So there we go. So kids will be making these, and they'll love these. These are a lot of fun. And that kind of concludes the forces side. Then we move on to magnetism. And in magnetism, kids explore these wand magnets, and they try and find what's magnetic and what's not. And so there's testing a lot of different materials, looking for magnetic and non-magnetic different objects. There's this read aloud. It's a digital read aloud called That Magnetic Dog, where just talking about the properties of what's it mean to be magnetic. And then there's a nonfiction read aloud called Magnetic and Non-Magnetic. And again, this is the short, modified version of this picture perfect lesson. We spent about 2 days total on introducing magnetism because students tend to have a little bit of background knowledge. We then go into an investigation, a magnetism investigation for a couple days, where we use a circular ceramic magnet and a paper clip, and a clothespin, and then we use some paper clips. And so students are trying to determine the strength of a magnet by making this little hanger, and then they hang paper clips on the hanger to see how many they can hang until it falls off. It usually takes about 10. And then they add stickers, little circular stickers to the magnet, and then they try it again, and then they add more stickers. So the idea is the farther the paper clip away, does it make it stronger or weaker? So does it affect the distance it travels? So that's a new investigation that's in there that I think your students will enjoy doing. And again, simple materials that you have in your classroom. And then finally, the last activity is students just trying to solve a problem using a magnet. So there's a bunch of different examples, such as trying to make a magnetic name tag or retrieve something that's fallen down into some water. But they can come up with their own problem to solve. For that problem solver, they don't actually have to build it. They can just design it, go through the design process and explore it, but they don't actually have to create anything in class. So hopefully that helps to kind of give you an idea of what this unit's all about, what's kind of in the science kit. Remember, you have your green trays, wherever the green trays are. So you have your green trays you can use for ramps if you need to. There's also a bunch of additional materials that you can. Please reach out with any questions, and I hope your students enjoy exploring forces in motion.